Hello and welcome back. My name is Corey, and well, I guess you're my rubber ducks for the evening. And this is the series of episodes where we are creating Tang, a new programming language, a language that we're designing from scratch. That is, we are writing a compiler, compiled to our own bytecode, and then a virtual machine to execute that bytecode. And yeah, that's what we've been doing. And we've been making every episode, our goal is to get to a steady state, to have improved our language in some way. Sometimes it's a refactor, sometimes it is adding new features. And lately we've been focusing on our string handling because that is one of the strengths of this language. That is, we want to be able to, yeah, sorry, my brain just stopped working. It does that a lot because I record these from my perspective very late at night after I work a full day and all that other fun stuff. So anyway, sorry. We've been working on our string handling and trying to make that robust because that is the strength of this language. It is meant to be a template parsing language, of course built in C++. That can be included in other projects, which I have other projects I want to use it on. But anyway, that's another story. So this is a language that should be incorporating all of the stuff that we know about Unicode and safe handling of, I want to say stuff, but that's a very generic word. Safe handling of data, maybe that's better, I don't know. And yeah, I'll just stop there. That's where we're trying to make sure that they're trying to mitigate injection attacks and things like that. So anyway, all right, so what are we doing today? I don't even remember. What's the title say? There we go. The Great String Refactor, Untrusted String Literals. And untrusted strings get escaped. Either sounds like something for our programming language or the mafia. You decide. But as such, let's, on the right hand side, do our standard make clean, and then we'll can't type, just getting started with a fresh compile. And on the left hand side, we will show a few things like git log. The very last commit was episode 64, the last one, the last the previous episode. That was the last commit. And if I say git git status, no changes have been made. So nothing up my sleeves. This is live coding, which means live errors and live syntax errors and logic errors, and we had to find them and still try to get something added. And our goal for today is we want to add untrusted strings. Right now, by default, all strings in our language are trusted, and we want to add a way of making them untrusted. Untrusted string literals. Right now, we can have an untrusted string, but we can't make it untrusted by how we define it. And so that's what we want to do. First, there's one additional test I wanted to write at the end of the last episode, but we had already gone a long time and I'd already made all my commits, and I was like, okay, well, we'll just do it at the beginning of the next one. So this test should pass, but let's just go into it. So test.cpp at the very bottom, and what we've got is we've got this make untrusted, and what I want is, so make untrusted I know I just stopped talking. It's because I was thinking about what's the trusted and untrusted strings. That's what we're going to do. So rather than didn't mean that, I meant that. And we're going to say A is equal to that. Is that how I'm wanting to do it? There. So A is equal to B, which is equal to H1. And then I'm going to say B is make untrusted. And we should, if we print A plus B plus A, it should print out H1, and then an escaped version of H1, and then H1 again. And I'm just going to make it intentionally wrong so that it will fail, so that I can make sure that it's printing out what I think it's going to print out. Yeah. Oh, look. Oh, the B make untrusted. It's not. If I look at what I wrote, we're creating a copy of it and returning the copy. So we're not setting it to be untrusted. We're making a copy of it. So I could have simplified this, and let's and I'll just say that's A. We don't need the B. There we go. And it is failing correctly. Of course, I could say B is equal to the A plus A dot make untrusted plus A, and then print that out. But I think this is actually fine. So, I need to set that to the H1, and now our test should pass. So this is, why am I doing this? This is an explicit example of showing the combining of strings, which is something that we wrote in a previous episode. And now we're finally getting to where we can test it and show off that, yes, this does indeed work. So, makes me happy. So, going to quit, get status, get diff. Yep. So, test showing trusted and untrusted strings. Okay. Now, we're going to go back into our test file because, write our test first. And we've got our untrusted string trying to think of where I want to put this. Alright, so this is, it's going to be untrusted string literal, whereas the other was just untrusted string. So, multi-line comment on its own line, blah, 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 yeah. No, we're not doing that. This is going to be simple test. And what would it look like? Well, I'm not going to do that make and trust thing. We want a syntax. And in fact, I think I want to say A is equal to that. Nope, that was the wrong combination of letters. There we go. So print A. And what should an untrusted string look like? I could use the trick that we just did a moment ago and say to make, but that relies on something that was kind of custom coded into, that is, we provided that make untrusted function explicitly. And I'm not saying that that shouldn't exist, I'm just saying we provided it. I would like to use that syntax, an exclamation point equals. To specify an untrusted string. Now, by the way, this will compile. The test will fail, but it will compile. Why? Because our current syntax that we have says an exclamation point means not. So the double quoted string is truthy, so it will invert to be a false value. So print A will be false. And which doesn't print out anything right now. So we have to add this recognition of an exclamation point equals. And the question is do we do that in I don't want it to be the same as, by the way, as this. It's not the same. I mean, this would be a string that is trusted and then the not applied to it. But this is like, it's a special construct of our language. And I think the best way to do it is, rather than do it in Bison, even though we could do it in Bison, yeah, I'm arguing with myself. We're not going to do it in Bison, we're going to do it in Flex. So, okay, so we're saving that, and now we're going to edit Flex. Which one? Our scanner. There's a couple things, a couple different ways we can do this, but right now we've already got a sort of a mode of double quoted string. We don't want to have to duplicate that, but we like the idea of, let's see, so we've got this string buffer. Let's add something that says indicates whether or not the current double quoted string is trusted, or I could have put that on the previous line, oh well, untrusted. And all that we need is a Boolean is trusted. It doesn't matter, because what's going to happen is, now we're going to say, what am I looking for? what was the name of that? Double quote string. So if I look for push the state and we clear the string buffer, all that we need to do is say is trusted is equal to what? Is trusted is, oh yeah, so this is just a bare one, true. But, and again, remember, Flex tries to match the first thing that it can, the first roll, the longest. So if I put an exclamation point, I have to, there isn't a single exclamation point somewhere down here. Somewhere down here. Well, there's an exclamation point. Where did I put the single exclamation point? Oh, right there. Which was before, of course, the exclamation point equal, but yeah. So what I'm going to do is, let's go back up. And say if / exclamation point that, then is trusted is false. Okay, now this will compile, but it's not going to do anything. We need to pass that is trusted information. How do we do that? It's two things. Okay, so is trusted as false. When we there, searching for that again. Here it is. So when we return it, string error, make string, the string buffer, we're going to pass is trusted as well. So we need to add that to Bison. It's going to give me an error here saying, hey, I can't do that. So that's because we need to edit Bison. Oops, didn't mean to do that. Didn't mean to close this either. Edit Flex. Even though I don't think we need to. Tang scanner. Bison. Tang parser. There we go. Let's go down and I've never tried to pass two things in. I don't think it will let me do that. Say, Corey, you should have thought this through. I know. Yeah. That is unfortunate. So we can do this as a pair of string and bool. That's fine. It's not going to compile because we need to go down to where we create these, and when we pop the state, return there. And I'm expecting it to now mess up in the Bison stuff. Yeah, Tang parser.o. Okay, that's fine. Oh, wait. No, it would be the parser. That is Bison. And what we need is, where do we... AST node string dot first we need to add this to the AST node. Yes, we do. $1 dot second. So that's breaking out the string and the whether or not it is what's the word I'm trying to say? Trusted. So do I use AST node string anywhere else? No, I don't. Okay, let's write that. It's not going to complain because AST node string is not correct, which guess what? We need to now edit the include for AST node string. And here's what I'm going to do. I'm going to make construct a trusted string because its default is going to be trusted. And then we're going to give another constructor where we can pass in a bool is trusted, construct a string that is either trusted or untrusted. Now we're not saving that. That is, we're not saving the is trusted because it goes into the Unicode expression. It's not actually part of the... oh, it's going to complain because we haven't actually written this function. So source AST node string and... No, we do need to. This just got a lot more complicated. Okay. Private. The string is trusted. is trusted. And now we're just going to say yeah, there was a faster way of getting to the end, but by default it's trusted. If it's is that what I called it? Is trusted? Yeah. It's trusted. Okay. Problem is, yeah, no, it's not able to run because we've changed something. Well, we're about to change other stuff too, so I'm not worried about that. The problem is the compile. Right now, to compile the literal, we get the length. We need what I'm wondering is, should we have a different opcode for an untrusted string, or should we pass that into our computed expression? Well, our documentation, let's look at it. Docs HTML index. There we go. So what I'm wondering is, what did I write for the computed expression string? That is, once we create this, not the make copy, set untrusted. I wrote that. I would rather do it here. So we're going to add either 1 or a 0, basically. I'm not liking this. So we add a bytecode for the string, and then for the length, and then we have to pack the characters into the different bytecodes? Yes. So this is the number of characters. Let's do this. Program, add bytecode, and it's going to be is trusted. Can I do that? Uinteger. And now I have to worry about when I dump it and everything else. Okay, so edit the source program dump. Okay, and string. So I've got the size, and we're going to say bool is trusted equals this bytecode PC plus 2 as a bool. All right, and then so the check needs to be a 2 here, and now it needs to be 2 plus the number of bytes. And PC plus 3 shifted left by all that. Okay. String. And now the question is, is trusted. If it's true, it will be that. If it's false, it will be an exclamation point. That. Okay. Let's do the same thing, but now for the program execute. Go down to the print statement. Same problems. We need, now we're doing a stack check of 2. Make sure we've got 2 values. And we'll add here the bool is trusted. Nope. I'm in the wrong place. That should not have looked for print. I should have looked for string. Yeah, I undid those. Here we go. This. 2, there should be 2 things there. Why? Because now we need our bool is trusted is equal to this bytecode of PC plus 2. And now 2 plus the number of bytes, go through, and this should become a 3, because that's where we're starting to look for our bytes that are stored. And there. The program counter now will skip. Ours, the size and is trusted, and then the number of bytes that are used. Okay. So if I say auto s is equal to Now that's getting to a computed expression. But I need to know that it is a computed expression. That's the problem. Okay, so yeah, I see somebody in the Twitch chat said hello. Hello. So, nope, I'll just say auto. There, okay, so we've got our temporary value. That's a garbage collected value. Now we need to get to the string inside of it. So auto ampersand s is equal to, we'll do a static cast of a computed expression string ampersand reference and pass in star temp. And I don't need this ampersand there. We'll just say s dot, is it called, what's my documentation say? This is, oh, set untrusted. That's what I was looking for. Set untrusted. And now we push back temp. But we only need to do this if not is trusted. There. Let's add a comment. If necessary. There. This should be extract the letters of the string from the bytecode. Okay. There. Just want an empty line. That should all work. Okay, on the right hand side we're going to do our standard make clean, and now just recompile. And what we're expecting to happen, well, is for our test to pass. Whether or not that's going to happen, have no idea. One step at a time. Whoops, I'm in the wrong window. So our test is where? At the bottom, right here. Now, it could, of course, have a syntax error somewhere. That happens. Hey, guess what? We have a syntax error somewhere. So when we are, our program execute.cpp, auto temp, evidently we already have an auto temp. Yep, there's a temp. It's a string. What do we want to call that? Naming things is hard in programming, right? How about a garbage collected string? Sure. Or a GC string. It's arguably a better name than temp. Okay, looks like everything's compiling. Let's see. We've got tests failing now. Ooh, that's not good. And we probably have an infinite loop going on. Because if you can hear it, my computer sounds like it's about to take off, which means we're probably in an infinite loop. Alright, so probably in this. So what all did I change here? So the git diff of our source program execute. I did change program check. The size is PC plus 1. Is trusted is PC plus 2. Bytes should be the right thing. That looks correct. All of this looks correct so far. Have an extra space at the end. Oh, that's unforgivable. We're gonna get rid of that at this exact moment. There. What else? Oops, it needs to be on the... thing that worries me is this all looks correct. So let's do cout here, and then GC string dump. Should be able to do that. Let's see what happens. Let's at least know if we got through this. That's interesting. Okay, you know what? Let's look at our tests. If I go to the very first one, 64. This is when we get the result. So Tang compile script. I want to see this. I want to see cout p1.dump bytecode. So I have several tests failing. The first one, line 64, which on the left-hand side, it's saying stack is empty, so that means it didn't execute. This doesn't look right. Okay, so the problem is it in the way I compiled it? Maybe. But what's kind of weird is this H. And I'm assuming that's line 72, which is the very next test. Hello world. It only put in the H. So, okay. Let's go back. What is temp? Temp is a string. This is a horribly slow way of building a string up, by the way. There. Just adding a to-do. I'm just going to say temp. I should see a string being built up. Okay, I don't know if you saw what I just did, but I did. Is trusted is first. And then the size is second. And that means when I'm reading it here, is trusted should be first. And the size should be second. Okay, and then compiling opcode string is trusted as first, followed by size. everything passed except, but we can see it here. Look, it's building up all of these strings, which is what we expect. By the way, that's why I said that this is really slow. In fact, that may be one of the things that's really slowing down our program. Oh my goodness, look at all of this. All these are memory allocations. Well, maybe, depending on what optimizations are taking place under the hood. But if I had to guess, it's a lot of allocations. Okay. So we can remove our cout here, remove our cout temp. And where we dump the bytecode for this first one, notice it's an empty string, so it has that. But now if I dump out this bytecode, I should get an exclamation point. Or not. So it failed the 1977, that, and it's looping on the dump. Okay. So that means I'm going to do the same thing I did just a moment ago. Get diff of source program dump bytecode. And what changes do we have? First of all, 2, that's right, is trusted should be first. And it's bytecode of PC plus 1. Cast to a bool. In fact, do I even need to do that? I might not need to. Let's find out. The size is the bytecode plus 2. There we go. Wait, so it just looks like it's not liking the size. All of that looks correct. Let's see what happens. Find out if this is where the issue is. So, alright, so we're not getting to the last out string, which means we'll probably have a really weird issue here. Cout I, J, and then we'll do that, and then cout inline. I mean, this is my first instinct that something's going wrong at this place. I have one other thought, because that looks like it exited correctly. And the thing is, let's see the diff again. I think, yep, bytes plus 2. I saw that right at the end there. And I believe that should be bytes plus 3. And now, yep. Okay. So, now first of all, we failed our test. But the other one, and now move up. That's what K does. I don't need to output. Well, I do need to output that. I don't need to do this cout, or this cout, because we're good. The question is why are we not getting the is trusted through? Go back and make sure that when we compile this, I mean, it is indeed, and we're dumping the bytecode. You see in the bytecode, it doesn't look like there's an exclamation point there. So if I edit the source of our dump bytecode, yeah, I'm on number 6. That's fine. What I'm wondering is, I just want to see. So that goes through. Let's do this. For auto ch in this bytecode. This is not meant to be a long-term solution. All I'm going to do is cout ch, which should be a number, and then a space. It's ugly. Definitely ugly. Okay. So 9 is our op null, 13 is our string, 1 is whether or not it is, so that it is there. It is, we know it's present in the bytecode. Because if I did the exact same thing, left hand side, on a string that is not, here, let's copy that dump bytecode. Sure, we'll do it there. So therefore, the string h1, it's 1 past that. So you see, but 13.1 for, this is 13.1 for. This one's trusted, this one is not. Oh, so that should be a 0. Yeah. Okay, so it's not getting there. It's not being properly encoded. Okay. Why? I'm glad you asked. It's time to find out. If it's trusted, it's 1. Otherwise, it's a 0. Is this failing? Is the question. Yes. Okay, so I don't think that that was the problem. I think we're always giving it that it is always it's always true. Didn't we have it defaulting to true? Did we? We had a way of creating an AST node string with that, and then is trusted with whatever they passed in for is trusted. Okay. See what happens. Okay, so, oh look, that right there. Everything is trusted, trusted, trusted. All of them are trusted. Except that one, which is correct. It should not be trusted. Hence the frowny face. So we know that we're calling makeString with is trusted. We know that Bison is passing that through. We know, what do we want to double check? Yes, let's double check. We can do this, and just instead of that, you can say $1 dot second $1 dot first. Yep, and there it is. We're getting this here. So now the question is, when we're encoding it, number 5. When we're compiling the literal, let's do this. The default constructor followed by text followed by endline. As opposed to this one, which is going to be special and followed by is trusted, which is either or a frowny face, followed by space, followed by the text, followed by an inline. Again, I just want to know which constructor is getting called. Oh! So we're creating it, and then the default is getting called. Why is the default getting called? Or rather, maybe I should say, where is it getting called? Because that's where we're losing it. There's a lot of constructors being called. That's not good. Contributing to the slowness of our program. The special is getting called a lot. This is only in the AST node string. Thinking about all the places in the program. So yeah, it's being called a lot of places, but well, and I am kind of curious as to why it shouldn't be called that many places. Oh, wait, but it's for each time we execute the program, right? Because this is an AST node. So this is in a compilation. Okay, that's more understandable for the number of times that we create a program. Okay, so I'm not going to worry about that as much. So make untrusted, if we look, which one are we on? We're on number 3. Okay. we've got two of these, right? This is a dump bytecode. Wait, up here. There. String h1. And that's this one here, where it is indeed, it's trusted, so that one's fine. And then we've got on the left-hand side, we've got 1, 2, 3, and then 4 programs before the final. So one is h1 in length, okay, and then another one, h1, there, that h1, and make untrusted, and these are being called when we're compiling in how to what name we're calling. That's fine. This is another h1, which is right here, and then the last one, this is an untrusted one. But where are we calling? Where's the second one happening? It's being called with a default constructor and why. Why? I think I know. And by the way, it was doing what I was just talking you through. That's why you're my rubber ducks. This is how I find out my problems. Okay, so in my AST node string, when I am compiling the literal, who calls compile literal? That's a good question. I think I have to go into the function declaration, program.cpp. Looky there, I'm constructing a string using the default constructor. That's where the problem is. So let's run that again with grep-n to tell me what line number it's on. 119. Okay. Edit. Oh. Wait. There we go. Get the right file open. realize my phone's on silent. So the problem is a string can now be either trusted or untrusted, and those are two different literals. That's an important thing to realize. And right now, this string literals this is bad. It's not bad, it's spiraling out to more. So when we compile, prepare the push environment. So the string stack. First of all, so we're going into the include for the program.hpp. So string stack. That's where we're starting off. Here it is. Strings to their stack location. And it can't be just a string. It needs to be a pair of strings and a bool. Are there any others? Push continue. Functions declared. Functions collected. Pair of a string, comma, bool. Add string, bool, and this would be is trusted. So and removing a param that was wrong. Get identifiers assigned. Identifiers, those, yeah. Add an identifier to the environment. Identifiers aren't trusted or untrusted, they're just default to trusted. Environment. Okay. And now the source for program.cpp. Let's just start at the top. It's not liking this. Can a map not be of a pair? Should be at least 2. That does not name a type. Expression error. I mean, we could simply encode it as part of the string, but I really, really, really don't like that. Or am I just, do I have a stupid syntax mistake? That's always possible. A map in which, you know what, I may just have to do this. Okay. So it's going to be a string. I don't like this. Wait. It took this one. So 188. What's my difference? Oh. Okay. Corey evidently can't type. That's a stupid thing to mess up on. Now I'm okay fixing other things, but now I want to minimize the amount of work I have to do, okay? So let's do this. Let's say So is trusted, and we're just going to default this to true. Okay, that's the first thing. Now that didn't fix this. We're gonna have the same compile problem, which was in the AST node function declaration. But let's get there. Let's write that. I mean, let's fix that. Edit the source for the AST node. It is in the source, right? Yes. Function declaration .cpp. All right. What it is, I know I'm staring at this, but what I'm wondering is, I know where the problem is, by the way. Yes, I can see that, but that is not the point. The problem is that I need to know whether or not we need to differentiate between trusted and untrusted strings at this place. So, what are we doing? This is why you're here as rubber ducks. What is the point of this function? We are compiling a function declaration. So prepare for new function environment. That's fine. We ensure that the arguments are listed as identifiers. Okay. So we're adding those add identifiers. That's fine. Say the start position of the function. Okay. Reserve stack positions for any variable in the body. First, we have to get a vector of stack names in the correct order. Okay. The identifiers, but of course identifiers aren't protected or unprotected. That's fine. Add an entry for each identifier. So nothing going on there. Put the string literals on the stack in the expected order. So figure out the order first and put that into string literals. Okay. Okay, I think I can handle that. Item first. So these are the strings. Okay, okay. So the program.getStrings is not going to return a map of strings. It's going to be a map of pairs of string and a bool. Let's get string, right? Get. Yeah, get strings. Okay. Get strings. returns this map of strings in a bool. Because, again, each string is unique. So, pair of strings and a bool. Can I do that? Answer is yes, I can. So now location. So that's kind of flipping the order. Now we can go through string literals, which is a vector of pairs, and say AST node string literal dot first, literal dot second, compile literal. That gets us past that point. That's progress. All right. AST node string. AST node string.cpp. That's fine. 29. So strings is, and it's going to be it's not is literal. Is trusted. Will that work to get me past that point? Okay. That's better. Making more progress. Now in program.cpp. Okay, good. I knew we'd have to fix some things here. And here I was thinking, oh, this is going to be a really, really short video. Line 42. Pushback. It should be a map of pair of string bool I figure there's several things in here that we'll have to change because we fundamentally altered what we're tracking. 115. We're going through the stack. String literals. What is string literals? Because they can each be separate. Where are we? First ever. Come on, come on. We can find it. 113. Wait, still 113. Bool is not a class struct. Oh. It's a vector of pair. Okay. Now line 119. .58 and add string. I think we need bool is trusted, and we add back Did I do this badly? 160. Oh. Yeah. Making progress? Because we've forgotten the whole reason. No, we were losing the fact that we were this. Okay, it's compiling again, and it didn't fix a thing. The problem is now, well, let's just back up. Notice we're using a lot of defaults earlier. Now we're all using the specials, which means we're explicitly passing through the values. The question is now, yeah, special and special, it should be there. Where are we losing it? Where are we losing the fact that it's not trusted is the question. A quick way of finding out would be in program.hpp in our include. The add string is trusted. Don't give it a default. And it'll start now telling us, oh, we need to edit this file, whatever. And this is in AST node string. Something I already have. Open. Compile pre-process. Add string. Is trusted. Now, just going to stop here and point out something. Right here. They're now matching. That's good. And that, I don't think, gave me the error. That's matching as well. So what failed? this. It's still failing. Okay, but let's look at our output here. We now have a 0. We now know that we're saying it's not trusted. That is, our dump is conveying that to us. The question is now, are we constructing it correctly? Because ultimately, what's the issue? Untrusted string literal. So when we print it, it should give us that. So the here is the just want to find out if we're running that code. Okay. It says that we are. What I want to know now is can I access is trusted? No, I can't. So computed expression string. So after doesn't that use the render? Yeah, okay, so look. Untrusted, and it's dumping as that. But here, H1, so is this making a copy instead of actually? Is this the same problem as we had last time where we thought we were, where we did everything on a copy or we were changing the wrong copy? Because, by the way, setting untrusted on that and printing it out is working. But when we get to here, and we're doing GCC string dump, we didn't actually change anything. Why? I don't think that will change anything. But wait, it compiled. Was that... Why do I even program? That was why! So we can get rid of our temps. We can get rid of our dump there. Because now we're passing our test, by the way, which is always a nice thing. Now, unfortunately, working with the pairs has caused our time to go up. So we need to perhaps come up with a better solution. But that can be a future optimization. But for now, so what do we need to do? Special and default, where on earth are those? Fast way. Get diff. Let's see. Here's one, astnode string.cpp. Is that what I'm in? No, I'm not. But B5. And the whole special or whatever. Line 12. Yep. Rerun our compile. Alright, now we're just doing our dumps. So, no, it was in the wrong window again. So our program X, no, our dump, we no longer need to dump the bytecode itself, which is this line. But it again, it does let us see 13.1 for 13 is the opcode for string, 1 is true, it is trusted, and 4 the number of characters, and then this is the encoded in the however many bytes, and then peak is opcode 1 into 0, and then 43 is the op print. But 13.1.4 and then that number versus 13.0.4 and then that number. That's the whether or not it's trusted. Okay. So we don't have to show the bytecode anymore. That's going to be there. Now go back to the tests and we can remove our dump bytecode because we know that that is working as well. Okay, so we didn't lose as much performance as I thought, but we're in between. We're bumping right up against 6 milliseconds. And there's definitely some things we can do to make this faster. I've been thinking about this anyway. We could attack, not use strings as much as string views. I already mentioned I put in the one to do. Yeah. Oh, so, okay, now that it's working, just write a few more tests and to make sure that it's working in different. So we've got an untrusted. I want to. So untrusted and trusted. String literals are separate. And we're going to do that by, we'll just say, whoops, B, print A, print B. Where the only difference is whether it's trusted or untrusted, and again, just for my own sake, I wanted to see the we'll run this. And look, yep, we've got two strings. And that's an A and a B, right? And so we're peeking 2, 0, 1, 2, and poking into 0, popping the result. Peek, poke, pop. And peek, print. Yeah. I think that works. But they are separate. That's what I cared about. They're separate. And then is that the main thing that we needed? So before we tested all this stuff with the untrusted string, and now for the untrusted string literal, just the fact that we can create one and that it's separate from a trusted string literal. Is there anything else we need to do with that? I don't think so. All right. Should we start going through? Everything looks right so far. Yeah, it's all in there. Git commit. And what did we do? Add support for untrusted string literals. And I like this. Add support for untrusted string literals. Only 98 insertions and 36 solutions, which means those were refactors. That's fine. Now we've got to rework our docs, so make docs-pdf. And at the same time, just let it rerun everything. You know? Oh, it's not doing that. Make test-j8. There we go. Do a lot of them at the same time. And everything is still passing. That's always a good thing. And update the docs for... What episode are we on? I don't know. Episode 65. Okay. episode 65. .065. Our message is episode 065. Okay, I'm actually really happy about this. I like what we did. Oh, we should do this. Make clock. Checking our lines of codes, we're pretty close to 9,500 lines. And again, 3,100 lines of comments. That's perfectly fine. And of course, if I reopen our documentation, where did we see change? That was with the program. Where's program? There we go. Just looking at this. Yeah. It looks really cool. I'll admit. I think it's neat. Oh, and you can hover over. So where's the string stack? Yes, there we go. And then the get. Where was that? Yeah, get strings. So it's updated. Okay. It's always a good thing. Had all of a sudden, well, now it's time to say goodbye, and then the Mr. Rogers ending song came to mind. No, we came to a good spot. We got a lot done. One or two bugs that I always have to track down to say, well, what's causing this? But in the end, we have better functionality, and I like, again, this is not my first time to write a programming language. This is my third time, and I've solved this different ways each time. And by the way, about this time in my life, I'm thinking that maybe it takes me 3 times to write something before I really like my solution. And what do they say? Weeks of coding can save you hours of planning. Maybe if I had thought through my solutions better, then I would be better prepared. But quite honestly, if you don't have any experience with this stuff, then you don't have a point of reference to come up with a good solution. And so I'm hoping that that's what I'm developing, a good point of reference, which means you've made a lot of mistakes along the way. And okay, so that's where I am. Made a lot of mistakes, and now we are coming up with solutions, nice ways of expressing these ideas of whatever. So in previous incarnations of my language, I focused on, well, when you print it out, you should know if it was trusted or untrusted. And I didn't use those words either. But now I'm taking a different approach. When it's created, it should be created as trusted or untrusted, and then that attribute should follow the string its entire life, whether it's being concatenated with other things or whatever. And so that means, we have to worry about what we did today. That is, when we're compiling our string literals, the fact that one is trusted versus another is not. Those are separate bits of information that we need to then convey to the that we need to store, and it needs to follow the lifetime of that string. So even though the characters themselves are similar, the contents are not. So yeah, that's that idea. So, is there anything else? Nope. That's it. So what are we going to be focusing on next time? Well, we've got this our trusted and untrusted strings working. I really want to start messing around with the idea of having a library that we can access. The problem is in order to do that, we have to have a notion of a compiled, a native function, not a native bound function. A native bound function is attached to an object, but just a native function that we can execute, and it needs to be able to pull data from the context of the world or of the program execution, which means we need to be able to supply a context that is arbitrary. That's going to be difficult. And we can do it, but it's going to take some work. All right, so having said that, I'll be coming up with ways to do it, because right now in my mind it's one big thing. It's like, well, we can't have this unless we have A, B, and C, and I'd rather break it down like I did with the string stuff. And you may feel that the string stuff has gone on way too long, and well, maybe it has for some parts of it. Some parts of it, especially the one where we did the initial slicing and indexing, that was a horribly long. And I say horribly long because remember, I'm working a full-time job and then do this at night. That was a horribly long episode, just because it took so much work to get us to a steady state to do that massive step up. But other parts of this have been a lot shorter, unless I have to chase a bug like I did tonight. So maybe my few hours of planning can save us a whole lot more work later, and I'll figure out how we can do this in smaller steps. So, having said that, I think that's it. We're going to bring it to an end. Thank you for joining me, and hey, I'm hoping that it's helpful to you in some way. Thanks for joining.